You may have to pull and snap at the finger stall to get the material that is stuck to the walls of the finger stall to come down and merge with the existing mass. You can see that there is a ball that is formed, right? And this should be of a very hard consistency. This should not be soft at all. As I said, if there is too much of powder, then this whole mix will feel gritty, it will not coalesce. If there is too much of eugenol, then in that case the mass will not form and it will stick to the walls of the glove finger. At this point, once everything is collected at the bottom and it's formed one nice cohesive hard mass, I can go ahead and take a scissor and cut off the top and dispense this mix onto a glass slab. It's a neatly rolled item and it's very hard. Now I pick up the barrel, any side is okay, and I will thread it. Can you see the contra angle? I'll thread it into the outer portion of the contra angle bit. It just basically makes it easier to hold, that's all. And just the way we load an amalgam carrier, we would sink the other end of the barrel and start loading this cement onto the barrel. You can see that there will be an air-free column of cement which gets generated in the bore of the barrel, and that climbs up all the way up the shaft to the top, almost the top. Should you fill to the top? Not really wise, because there's something else that's going to come at the back. If I have the driver rod seating here directly, then the driver rod will get stuck into the cement and will not allow it to advance smoothly. Therefore, to seal the back end and not allow the driver rod to come into direct contact with the cement, we will introduce this nylon ball valve at the back end of the barrel. This nylon ball valve is in dimension slightly bigger than the internal bore of the barrel. So it needs a considerable amount of force to get embedded into the back end. As it does get embedded, it will warp a little bit and accommodate itself into the bore. This back end slight cement which is remaining should be ideally removed with a brush or with a probe. The packing of the ball has caused the balance cement to come at the top, to the top. Now you have an entire barrel full of cement. You can, if you wish, turn it around and press it on top of the existing cement to have it again air free. The back end now is sealed airtight. Now the needle that we are going to use comes to you from Pulp Tent Corporation. It's sealed. You break the back end of the seal, open it up, discard the back, and the needle has a steel hub which will be threaded onto the front end. Once it's threaded onto the front end, the threadings are not so tight that it will seal off this exit point. Hence, to seal off this exit point, we will use two washers, one or two washers, as much amount of washers as are required to close up that space, that balance space. Usually I like to use two washers. We just place them on the front end. Mind you, the back end has the ball valve. The front end is going to accommodate these Delrin washers, as we call them. I have two of them here. Now when I pack the needle or thread the needle in, this end of the hub will sit against the nylon ball valve and not allow any leakage to happen in this area. That is the beauty of the Delrin washer. This hub is empty. If I just thread this without anything and go cranking from the back end, most of the cement will be occupied in filling up the hub. So it's better to fill the back end of the needle hub with a little bit of cement. When these two meet, you will again have an air-free column of cement within this whole system. Hand tightening of this needle against the washer is not sufficient. You need to hand tighten and then turn it a quarter turn additional. This is the purpose for which these two small little spanners have been provided in the kit. The larger one fits onto the barrel, cement barrel, and the smaller one fits onto the hexagon of the needle hub. You tighten quarter turn, just 90 degrees, and you're done. This assembly now is ready to load. The only thing that I would possibly want additional is to get this cement out. You can keep a small toothbrush or use a small probe for that purpose. That's it. We had advanced the micrometer screw quite a bit. I take this driver rod. Now you see the reason for that recess. That recess fits properly onto this ball valve and gets threaded in. Now I can advance the micrometer screw so that it starts encountering a resistance. The initial resistance that will be encountered will be when the cement is pushed into the balance of the needle hub. We filled only a little portion of the needle hub with cement before loading it. The balance of the needle hub now needs to get occupied with cement. So this is the initial resistance that we are going to face. You can see that it is freely turning